Okay, welcome to part 3, guys. So hopefully this will be the final part. Okay, so there's a bit of maths now involved in this. So all along it's been a bit of theory, okay, for energy. So in this one, we're going to hit the second last, learning intention, define power, state the equation, and we're going to hit the last two keywords that we need to cover, work and power. Okay, so we're going to hit those. So we'll get back to where we were, okay? So, heading here, guys, energy in the home, okay? All right, so energy in the home. All right, so the next few subheadings are going to be based basically around this. Okay, so we use energy in the home and throughout our daily lives. Heat loss occurs the most, as you can see here. Your roof loses 25%, 10% usually the windows. The walls lose about 35%. The floors 15%, and then other drafts, draft under the door, etc. Open windows, etc. All right, so that's where you lose most of it. So now insulation will try and reduce this as much as possible. Okay, now insulation will reduce the rate of heat loss, but you'll still lose heat in the house. Okay, the heat will still manage to get out, just because the windows, guys, the windows, it'll always get out through the windows. You could have double glazing, triple glazing, it'll eventually get out. Okay, same with the walls, you can get insulation to reduce the heat loss, same with the roof, but it will eventually get out regardless. Okay, so heat will get out. Okay, it's impossible to keep the heat trapped in indefinitely. Okay, so that's kind of the main areas that you'd lose. Okay, now generally in the exam, what they'll do is they'll give you a picture like this and ask you how do we fix it. Okay, so we fix it with this. You don't need to put in insulation. Your heading is still energy in the home, guys. Okay, so insulation. So take down this. Insulation prevents and reduces the heat loss in a home. Okay, so insulation prevents / reduces heat loss in a home. All right. So what are the types? Well, there are 5. Okay, so these are all 5. Take down all 5. Depending on the question, you might need to ask. So fiberglass in the attic, or glass fibers, what they call it. They also have this thing now, a new thing, which is like a foam that you can spray on the roof, and it'll create a foam type thing that'll stop the heat from getting out. Lagging on the water tank, double glazing windows. Now you have triple glazing windows is the new thing. Air cavity in the walls. In other words, there's a cavity. Old houses didn't have an air cavity; they used to have a solid wall. And what happened is moisture used to get through the wall, and it'd be very cold. And now they can do internal insulation on the walls, but most new houses have an air cavity. And well, built in the early 2000s, they probably didn't insulate the cavity, whereas nowadays they're always insulating the cavity. Okay, insulate it. Okay, to prevent heat loss, and then of course insulate the pipes. So all the attics and all the pipes will be insulated to prevent them during the frost and the cold weather from freezing over. Okay, so take down all those points. Again, pause the video, guys, as you do it. So, our next subheading, energy efficiency. Okay, so what is energy efficiency? Okay, why are new bulbs considered more energy efficient than the old filament style bulbs, and how can we define it? Energy efficiency, guys, is defined as follows. It is the minimal amount of energy needed for an object to do a task. It is the minimal amount. Okay, all right. So in other words, if your job is, say, if there's an electrical thing and its job is to actually look at your phone. Your phone's job, let's say well, maybe not the phone, it's a mini computer now. But one of the things your phone isn't meant to do is give off heat. Okay, that's one of the things your phone isn't meant to do. Okay, because if your phone is giving off heat, then that means the battery and the electricity is being used to generate heat. Okay, so it's wasting it. That's why certain phone covers, guys, you have to be very careful, is that they trap the heat in and they make it hot. They heat up the phone and your battery goes down quicker. Okay. Same with light bulbs. With light bulbs, guys, their job is to create light, not heat. Okay. So new light bulbs don't create an awful lot of heat, whereas the old ones did. Right. And again, there's a short video I'd advise, go back and watch that. Now, a good example here is this. These are called Sankey diagrams. All right. So as you can see, 100 joules of energy is coming in. All right. And the light bulb, it's a light bulb. 75% is used for light and 25 goes off as heat. So a quarter of the energy is lost as heat. Okay. There will always be some heat loss. You will never get 100% energy efficient. Okay. That's kind of the easy way to draw. You can draw these kind of diagrams, guys, to show anything. Okay. To show that the majority. And what you always do is the arrow that goes off here, this arrow means it's a kind of excess heat or wastage. Okay, it's not fulfilling the function. Okay, all right. And for example, here, heat energy. This would be an inefficient bulb. Okay, so this bulb here, 98 joules. So the old style bulbs, the majority of the electricity came as heat, and very little of it came out as light. Okay, so the 100 joules went in, and only 2 joules was used as light. Okay, that doesn't happen anymore now. Of course, it's cheaper electricity and everything. Okay, now We're now on to a new topic, work. So next heading, energy and work. Okay? So, the more we move, the more energy we use up. In other words, the more work we do, the more energy is required. But what do we mean by work? Well, work is done when a force moves an object. You see, that's it. That's all it is. That's your definition. What is work? Work is when a force moves an object. You lifting your hand, that's a force to lift the object, your hand up. Okay? That's force moving the object. That's your work done. Standing up, that's the force moving your body to stand up. Okay? So work is when a force moves an object. And its SI unit is joules. Okay? So the SI unit is joules. Alright? Now, because it's joules, what does that mean? That means it's a form of energy. You see? So work is a form of energy. Okay? So work is a form of energy. Now again, in junior cert, it's nice to know that, but in even cert, that physics is very important. So when we move something, what two factors will determine the amount of work we do? Can you think before we move on? Okay, so take down the first point and the second point and the third point here. Okay? And of course, just say here equals energy. Take that down as well. All right? So work is energy. Work is done when a force moves an object. Its energy is joules. We know it's a force moves an object. So can you tell me now, can you apply what two factors will determine the amount of work we will end up doing? Any ideas? Think about it for a second. What do we think? Well, all right. The amount of work depends on the force applied, which is newtons, and the distance moved, which is in meters. Okay? So it's the force, how much force are you pushing, and the distance. So for example, if I told you to sit up from the chair, that wouldn't require as much force as if I told you to walk up the stairs. Okay, so the stairs would be a greater distance, so therefore you're going to do more work than just standing up. Okay, so therefore your equation, work is force times distance. That's it. Work equals force times distance. That's all. W equals F times D. Okay? And work is done whenever you do anything. When you move in any way, work is being done. Okay? So work is force times distance. So take down those 2 points, guys. Okay. So test you. Take down these 2 questions. Okay? So take down question 1 and question 2. So write in the 2 questions and then try and answer them. So the first question to try and answer is find the work done when a force of 6 newtons moves a glass at distance of 0.5 meters across the counter. So take that down and then try and answer it. So when a force, and take down your information, a force of 6 newtons, a distance of 0.5. Go back here, force times distance, you see? All right, that's all it is. What answer do you get for that? Now, obviously pause the video, guys, so you hopefully have that done. So part 2, find the work done by a weightlifter who lifted 900 newtons from the floor to a height of 1.6 meters. So force and a distance. Force times distance. Okay? So do the maths in that one. Okay. So I'm assuming you got that done. You paused the video and worked away. Let's have a look. So question 1. The equation is the same for both. Work done equals force times distance. So question 1 is, wrong one. 6 times 0.5. 6 times 0.5. 3 joules. Question 2 was 900 by 1.6. 900 by 1.6. 1,400. Done. Okay? Nice and simple. Okay? Alright. That's it. That's all it'll ever be, guys. Very straightforward. Now, power. So we're now on to power. We're almost finished this topic. Okay? So power. We now know how to calculate the amount of energy needed to perform a task. However, we never considered how time would affect this. Why would time be important? Okay? So why would time be important? Right? So for example, if one was to climb a hill in 5 minutes and the second does it in 2 minutes, we'd say car 1 is more what? So if 2 cars going up a hill, one gets up in 5 minutes, the other gets up in 2 minutes, which car? We'd say, well, one car was what? It was more powerful. Okay? So what is power? So take down this, guys, your definition. Power is the rate. Power is the rate at which work is done. Okay? Power is the rate at which work is done. Okay? The SI unit of power is the watt, the capital W. Okay, so take down the first point, take down the second point. And our equation then, power is work done divided by the time taken. So power is the rate at which work is done. The SI unit is the watt, and the average power is work done divided by the time taken. Now, the good news, because it's physics, this can be given as your definition, because that's the same thing. The rate at which work is done, power is work done divided by time. So you can either give the bit in red at the top, this bit here, or you can give the equation at the bottom. Both mean the same thing. Okay, so take down all 3 points. All right, so what you should have down there, guys, is 1, 2, and 3. Okay, and it's up to you then which definition you want to go with. Okay. Now we're on to the last thing here. So we have 2 questions, and then we look at the common questions at the end then. Okay, so a girl of mass 60 kgs, so a girl of mass 60 kgs, which means her weight is 600 newtons, remember you multiply by 10, climbed a 6-meter high stairs in 15 seconds. So girl, 600 kgs, 600 newtons in weight, climbed up 6 meters of stairs in 15 seconds. Calculate the work she did first. Calculate the average power. So I'll give you a second. So calculate the work, calculate the power. What do we know? We have a force here. Okay? We have a time here. And we have a distance here. So calculate the work first. What is work? Force times distance. What is power? Power is work divided by time. Okay, so there are 2 equations. That's all you do, guys. Piece it together. Okay, so you should have paused the video and worked it out. And I'll look at the answer here now. So solution number 1, work done is force times distance. So 600 times 6, 3,600 joules. The trick here, guys, remember, that's the force. This is the mass. Okay, you don't go with that. That's the trick they could catch you here. They could give you the mass. You multiply it by 10 to get the force. That's the only kind of extra thing. Now, that would be a very higher order question if they did that, to be fair. That would be a higher order question. Generally, they'll give you it in newtons. Okay, so part 2 then. Power is work done divided by time, which we got as 3,600 divided by 15, 240 watts. Now, the question somebody's going to ask me, what if you got the work done wrong up here? Well, this, guys, is why I'm telling you, and I always say it in science, if you stated this equation, and you stated this equation, and you got the maths wrong here, you'd get most of the marks for getting the equations right. Okay? So give the equation. All right? So if everything else goes wrong, at least you got that right. Okay. Let's go back up to our learning intentions. Can we define energy? We've that done. Energy has different forms: conservation of energy, sustainability, define power, state its equation, and show the conversions. Keywords: work, power, energy, renewable, non-renewable, conservation, stability. Okay, so we've got quite a good bit done. We've got the whole thing done. So what we'll do now is we'll have a look at a few extra common questions here. Okay, so name the energy from the sun that the solar panel changes into electricity. So name the energy form from the sun that changes the solar panel into electricity. So think there, can you answer that? Number 2, the electrical energy is then changed into a form of energy that can be stored in a battery. Name the form of energy that can be stored in a battery. Okay, so name the energy from the sun, light or solar energy. Okay, the electrical energy is then name the form of energy that can be stored in a battery, that is chemical. Why? Because it's going to go chemical to electrical, electrical to light. Okay, so there you go. So in a battery, it's chemical. We chemically store it. Okay, so common question number 2. So these are kind of exam paper style questions, if you will. Light from the sun is a renewable source of energy. Ireland only uses about 2% renewable sources to meet current energy needs. Name 2 energy sources including sunlight that are available excluding sunlight, so you can't use solar panels, that are available in Ireland. Well, for Ireland, 2 easiest ones would be the wind, because we've lots of wind, and then we have to go with hydro. Okay, so wind and hydro. Okay. The next one, give 2 benefits that Ireland could get from increasing the use of renewable energy sources to meet our energy requirements. So there's lots of things you could say there. lower CO2, cheaper electricity because of that, less reliant on other countries, and more sustainable. There's hundreds of answers, guys, you could pick there. And in the marketing scheme that year, that's what they did. They have lots of answers, lots of options. Okay, so that is the end of energy. So it took 3 parts. It was quite a long topic. If you have any questions, please do leave it in the comment section below or on the Teams page. And we'll talk to you again.